Let's have another challenge. Create a program that will determine if the inputted year is a leap year or not. Year must be greater than 1582. That is the first year of Gregorian calendar. Note that every leap year is divisible by 4. However, if a year is divisible by 100, it must also be divisible by 400 for it to be a leap year. So examples of common years are 1700 and 2100. Those are not leap years. And examples for leap years are 1600, 2000, and 2400. So let us analyze the problem. Here we are given two conditions for a year to be a leap year. First, year must be divisible by 4. Second, year must be divisible by 100 and 400. So if it is divisible by 100 and not by 400, then it is not a leap year. Now, it is very tempting to jump right in and put all these conditions in if statements one after the other. Maybe you will do it this way. For year divisible by 4, you have year modulo 4 equals 0. And for divisible by 100 and 400, you have year modulo 100 and 400. And then if none of this is true, you put else and then print not a leap year. At first glance, this might look perfect, but it's actually easy to look for loopholes. One is, if you input 1700, the answer is supposedly not leap year, because 1700 is not divisible by 400, and it was stated in the conditions that if a year is divisible by 100, it must be divisible by 400 as well, in order for it to be a leap year. But if we run this code, the answer is leap year. And now, it starts to get challenging. That if you only lay all the conditions out in an if statement, it is easy to miss important conditions. Going back to our code, what makes this incorrectly identify 1700 as a leap year is the first condition, the modulo 4. Because 1700 is divisible by 4, the code printed out leap year and then it's done. To correct this, let's make use of Flowchart to aid our analysis. Now, here are the shapes we are going to use. The terminal symbol will be used for the start and end of our program. The next symbol is the input symbol. This represents an instruction to an input device. So example for this, if we take an input from the user, then we will use this symbol. Next is the process symbol. We will use this one if we are going to do some calculations or mathematical operations. Output symbol will be used when we are going to display an output or message to the screen. So for example, if we are going to use printf, then output symbol will be used. The last symbol is the decision symbol. This is for conditional control structure. Example is if we are going to use switch or if statements. Using those symbols, let's analyze the problem. First, we just need to denote the start of the program by adding the terminal symbol. Next is the message to the screen instructing the user to input a year. We use the output symbol. Next step is to take in the inputted year and store it to the variable year. And for this one, we will use the input symbol. Now, this is the start of the analysis of our conditions. Remember that our first condition is if year is divisible by 4. Decision symbol will always have two possible outcomes, if the statement is true or false. If year is not divisible by 4, then there's no need to evaluate it further. It will print out not leap year, and that's it. The program will exit. So let's connect false part to the end of the execution. Now, it is not the case if the inputted year is divisible by 4. Remember the case of year 1700. It was incorrectly classified as leap year even though it is not, because it satisfies the modulo 4 test expression. So therefore, if it is true that a year is divisible by 4, we must do further checking and not just stop there. And that brings us to the second condition. If year is divisible by 4, we must check if it is divisible by 100, because if it is, we must check if it is divisible by 400 also, before we can classify it as leap year. Otherwise, if a year is divisible by 4 and divisible by 100, but not with 400, it is still not a leap year. To do this in our flowchart, we must add another decision symbol under the true direction of the divisibility by 4 condition. And then in this symbol, there are also two possibilities. One is, it is true that the year is divisible by 100, and the another one is false. Now, at this point, we should only check if the year is also divisible by 400 if that year is divisible by 100. If it is not divisible by 100, then it is leap year and no further checking is needed. We output leap year and then end of the execution. For the true side of divisible by 100 condition symbol, we must add the last condition, that is divisible by 400. If year now is not divisible by 400, then it is not a leap year. But if it's divisible by 400, then it is a leap year. And that's the end of the program execution. Let us try to trace the flow if we input 2100 or year 2100. 2100 is not a leap year. So let's check if our flowchart is correct. Here we start our program. Ask to input 2100 or 2100. Store 2100 to year variable. And then evaluate if 2100 is divisible by 4. It is true that 2100 is divisible by 4. And so we go to the true path. Along the true path, we have additional decision symbol. Is 2100 divisible by 100? Yes, it is true that 2100 is divisible by 100. And so we proceed to the last decision symbol, that is, if 2100 is divisible by 400. This time, it is false that 2100 is divisible by 400. And so we follow the false path, and there we have to output not a leap year. It is correct that 2100 is not a leap year. How about if we try 1712? 1712 is a leap year. Let's try that out in our flowchart. Start the program, ask to input 1712, and then store 1712 to variable year. And then check if 1712 is divisible by 4. Yes, it is true that 1712 is divisible by 4. And so we do some additional checking if it is divisible by 100. 1712 is not divisible by 100. The false path indicates that we print out and classify 1712 as leap year, and then end the execution. It is correct that 1712 is leap year because it is divisible by 4 and not by 100. So our flowchart is correct. Let's convert our flowchart into C code. After all, That is our ultimate goal. For the start, we just put here the preprocessor directives and the imported libraries and the main function. After that is the output or message on the screen to input a year using printf. Notice that we just included the declaration of the variable year as part of the starting point of the code. You may add a separate process symbol for the declaration and initialization of a variable, but it's not that important for now. We are mainly after the flow of the execution, especially that of conditional or iterative control structure. Next is the saving of the input value using scanf. Notice the symbol being used. It is the input symbol. And for the decision symbol, we will use if statement and the test expression being used. That is, if the inputted year is divisible by 4. Notice that we must add the else block to output not leap year if the year is not divisible by 4. For the decision symbol, checking if year is divisible by 100, it is under the true path of the first decision symbol. So we must put an if statement under the first if statement of modulo 4. And here, we add a test expression of year modulo 100. Now, this is becoming a nested if statements. An if statement inside an if statement. This time, we also add else to handle those years which are not divisible by 100. And then, we output leap year. And for the final checking, we add another if statement. Inside the divisibility by 100, we use the modulo 400 as the test expression. Unlike the preceding if statements, we also need to handle for the false conditions, and we put else and then print out not a leap year. Under the if block of modulo 400, we add the printf leap year. And we are done converting our flowchart into a C program. Let us run the actual program and input 2100. It is correct that 2100 is not a leap year. How about 1712? It is also correct that 1712 is a leap year. And we are done. This is not the only way to answer the leap year challenge. Here's another form of flowchart and the corresponding C program. Notice the use of logical operators to achieve a shorter and cleaner program. And here are other versions of the solution. Try to study and explain the approach.